Outline. I'll give you a little bit of a summary. I'll give you some background. I'll talk about the One Oklahoma Cyberinfrastructure Initiative because that helps motivate the One Oklahoma Cyberinfrastructure Initiative AI Consultants Program. Then we'll talk about AI consultants. We'll talk about training and workforce development, some of the people involved with the project, how we're recruiting for the project, what our sustainability plan is. I probably will not have time to get to the evaluation plan, and there's actually a reasonably high probability I won't even get to recruiting, but we'll just see how fast I talk and how long I go. And by the way, I can go on and on about this stuff. I would encourage you to interrupt me if you have questions or comments. Don't be shy. All right, so quick summary. Here's the grant number and so on. It is 1.8 million over 3 years, so it started just about exactly 6 months ago. I'm the PI. The co-PIs are a couple of CS faculty here at OU, but we have senior personnel through other units at our institution. So we have I think she's a senior associate dean for libraries. We have a faculty member from our Polytechnic Institute, my boss, the CIO, the current director of the Data Institute for Societal Challenges, and then our evaluation team from Indiana University. Uh, so quick summary. So what we're doing is we're putting together a cohort of 5 AI consultants, and they will be available across the state. Any non-commercial, non-clinical STEM research project across Oklahoma is eligible to make use of the AI consulting service. Non-commercial because it's federally funded and we don't have a mandate to do that, so we have implicitly a mandate not to. Non-clinical because it's NSF and the NSF is not allowed to fund clinical research. STEM because it's NSF and the NSF is only allowed to fund STEM research in round figures. So these 5 AI consultants, 3 of them are professionals, 2 of them literally starting today. Yesterday. They started yesterday. One of the professional positions we're going to have to re-advertise. We lost our candidate for that one. We have a grad assistant who's actually been working since January on this, and we have our final interview for our undergrad specialist this Friday. Um, Next Friday. Forgive me. We already have recruited 94 research projects from across Oklahoma. About 2/3 of them are at OU, and about 1/3 are spread out among 8 other institutions, including our state's 2 other Ph.D. granting universities, several non-Ph.D. granting universities, and a couple of non-academic institutions. They will not only be doing the AI consulting, but also creating AI training. We will create a virtual residency-like program specifically targeting AI consultants. Now, of course, there's a lot of overlap, and I'll go into more detail as we go through this, but that means we will also be having them participate in the virtual residency in addition to the AI consultant program. And the institution has committed to at least one FTE to be retained long-term, funded via internal funds, institutional funds. Okay, so that's the summary, and we're going to dig into some of this stuff. So what's the background of this? So our theme is, and I'm going to over-exaggerate this because it's not literally true, but there's at least it's truthy and in a truthful direction, that we are encouraging the establishment of a at least largely new cyber infrastructure profession or occupation, the AI consultant. I think historically, it took a decent number of years for cyber infrastructure facilitators to become normal, and now they are not merely normal, they are ubiquitous. Most R1 institutions have CI facilitators. A substantial fraction of R2 institutions have CI facilitators. And there are a good number of non-PhD granting institutions that have CI facilitators, as well as, of course, non-academic institutions. I haven't made a careful study of the commercial side of this, so I can't speak to the numbers there, but In round figures, my best guesstimate is the community of CI facilitators is on the order of low four figures, one to a few thousand people across the country. Um, so the proposal that we wrote, and that is now a grant, the focus of the budget is hiring the AI consultants. That's where almost all of the grant money goes. Not literally all of it, but almost all of it. And as I mentioned, three professionals, two students, an undergrad and a graduate assistant. And that will help us create a workforce pipeline where we have people learning how to do it from an undergrad perspective. We have people learning how to do it at the graduate level, and then we have multiple levels of experience among the professionals. One of the things that we've been discovering from the interview process with the undergraduate candidates is a substantial fraction of undergraduates think that AI is identically the same as large language models. We know that that is not the case, but that is a very common perception among people who have not had exposure to other AI aspects, whether in the context of research or elsewhere, although I think most commonly in the context of research. So they're not thinking about things like image classification or dynamical systems or anything like that. They're just thinking about large language models because that's where their experience is with AI. As I mentioned, we've got 94 research projects signed up, 68 of them from OU, the remainder from 8 other institutions across our state. And we have a sizable advisory committee, both within Oklahoma and then at national research computing organizations. And we're going to dig into all of this. Now, this raises the question, well, why the heck would they be trusting us with this? Because, I mean, it's low seven figures, but it's seven figures. That's pretty significant. Um, and I would argue that the reason that they came to us is because we have experience creating national workforce development programs in the context of cyber infrastructure, in the context of research computing. So we have the virtual residency program, which I think certainly several of you have been involved in over the years. We have the relatively new Becoming an Institution Level Cyber Infrastructure Leader program, which started last year. And by the way, the virtual residency workshop this year will be June 22nd to 26th, so the last full week of June. If you haven't already registered, we encourage you to do so, and we will be sending you plenty of recruitment spam on that regard. And the same with the Becoming an Institution Level CI Leader workshop, August 5 and 6 this year. And we have already worked out the schedules for both, and now we're about to start recruiting speakers and panelists and moderators for both of those workshops. And then the Cyber Infrastructure Leadership Academy, we are expecting to run the next workshop for that at the Coalition for Academic Scientific Computation fall meeting this year. It was to have been in the spring, and then the NSF said, here, run this workshop instead. And so CASC did that, and that was a great workshop, and I was very happy to be invited to that. And so we shifted the CI Leadership Academy workshop to the fall. That has sort of two levels. One level is improving the CI leadership skills of institution level CI leaders, and the other is helping institution level CI leaders to become national CI leaders. And the reason that that's so important is because many of the national CI leaders got there by spending a lot of time being CI leaders, and so they, as we all do, got older and then retired. And so we have this brain drain problem, and we want to make sure that we are dragging people upstairs kicking and screaming so that we continue to have solid national leadership for cyber infrastructure. So the CI Leadership Academy has had 5 workshops so far, starting in 2019, and then we're planning a 6th for this fall. Okay, so the other thing that has been very successful in Oklahoma, not just at OU, is we've been very successful with the OneOklahoma Cyberinfrastructure Initiative, which I'll dig into a little bit in a moment. But this is our statewide cyber infrastructure collaboration. And we have become, in almost a literal sense, the poster child for statewide cyber infrastructure collaboration. And what I mean by that is most of the national meetings I go to, if there is a speaker from the National Science Foundation, there is a very high probability that they will have a slide about OneOki or about the One Oklahoma Friction-Free Network, which is our statewide science DMZ network. Um, and so this is a side effect. The One Oklahoma Friction Free Network is a side effect of the One Oklahoma Cyber Infrastructure Initiative. Um, so let's talk about OneOki. And by the way, it's pronounced that way on purpose. It goes back to fall of 2008 um, when the NSF. So Oklahoma is an EPSCoR state, so the established program for the stimulation of competitive research. Some of you may be familiar. Y'all are so busy at OU. God knows that's true. I don't get a lot of free weekends, if that's what you mean. Yes, that is true. Um, in 2008, the NSF put out their regular call for what was then called NSF EPSCoR Research Infrastructure Improvement. They didn't even have like track numbers, track one, track two. Later it would be called track one. Now it's sort of a combination of eRISE and eCore. There's a lot of terminology floating around. Doesn't matter. But it was a $15 million proposal uh, to be shared across Oklahoma. And for the first time ever, the NSF put the word cyber infrastructure in the solicitation, which they put it in 18 times. So you knew they were serious about it. And so I got this panicked call. Hey, Henry, we need a statewide cyber infrastructure plan. And I had as a gleam in my eye getting permission to share our resources with researchers across Oklahoma. And so I rubbed my hands in glee over my little evil scheme that I realized I could have, which was we could suddenly have the ability and the blessing of the institutions to share our resources across the state. And so we got into that business. Initially, it was OU and Oklahoma State, our beloved sister and hated rival. And over time, we've added other resource provider institutions in the state, University of Central Oklahoma, Langston University, which is Oklahoma's only historically black university, and Oral Roberts University. So all of us provide resources. And if anybody comes to us and sends us an email or whatever and says, "Hey, I want to get onto your machine," if they are non-commercial Oklahoma research or education, the answer is yes. And the same is true at the other four institutions. So we share things. We've been doing this since fall of 2008, sharing things. And we also share people in the sense of we share the expertise, not literally the labor, but we share the expertise. We pool our expertise. When someone at an institution needs help with something, the others are available to sort of coach them and provide them, among other things, peer mentoring, how to do things, and especially how to get funding. So we've been teaching each other how to write grant proposals over now, whatever it is, 18 years. And that's been extremely successful, and I've got a slide coming up. And our primary mechanism for accomplishing this is we have a phone call every week. Unfortunately, I had to miss yesterday's phone call. That was sad, but I had a conflict and couldn't make it. We occasionally get together in person, but really it's just the phone calls. And the thing is, there's sort of a core group of people who participate regularly, and then a whole bunch of people who come in from time to time. They come from all kinds of different backgrounds, primarily but not exclusively academic. OneNet, which is part of our state regents, is probably the most active from the government side, and then we get some participation from, for example, nonprofit research organizations. For a while, we were getting very good participation from the Laureate Brain Institute in Tulsa, which is a nonprofit research institute. So what has that led to? The biggest thing is it's led to a huge number of grant proposals for cyber infrastructure. And a shockingly high fraction of them have been funded, to our delight and the delight of the various masters that we serve, um, except for me, and it kind of ticks me off because I am the least successful in terms of percentage of proposals as PI funded. I'm running a little worse than 50%, which, by the way, is better than average for the NSF, but is far worse than average for OneOkie. And so it's kind of embarrassing when all of my peers have a far more successful track record than I do. So this fosters a lot of collaboration among our institutions, and a lot of peer mentoring among our CI leaders statewide. This has been a huge, huge win. And part of the great part of this is that when we have, for example, students or researchers or whoever participate in these calls, they come away with useful stuff. With students, of course, we are helping them get ready to say bye-bye because once they've done this, they can go out there and make 2 and 3 times as much money as we could pay them. So we love that they are having this success, and we hate to see them go. And we have a lot of fun. My experience is people are more likely to participate in a thing if they enjoy it. What a big shock. So we joke and we kind of tease each other. We have a good time. And it's kind of like, you're on a driving trip, and it's pelting down rain, and you're gripping the steering wheel with like the blood draining out of you. And you go under an overpass, and just for like 2 seconds, you're out of the rain, and you feel so much calmer for like 2 seconds, and then you're right back in it. Well, that's kind of how we treat this weekly call, that this is your refuge from the rest of your week. This is the respite that you get. And the rest of your week, you're pelting hell for leather. Um, and there's colleagues and there's work friends, and we've, I think, worked really hard to be work friends rather than merely colleagues. Okay, so to prove that I'm not lying, and forgive the eye chartness of the list, but the list has just gotten really big, and I'm not going to waste like 6 slides on this. But we've brought in, since we started OneOkie, we've brought in $23.5 million on 29 cyber infrastructure grants to 35 institutions across the state over a 17, almost 18-year period now. 17 and a half year period now. So that's a mean of $1 million for a year in new cyber infrastructure grants to Oklahoma. When we compare that to pre-OneOkie, we have improved by a factor of 13, by 1,300% in the amount of external funding that we've been able to acquire for research computing, for cyber infrastructure under OneOkie. And we're fiercely proud of that and brag on it all the time. Okay, so now let's turn to the Oklahoma Cyber Infrastructure Initiative AI Consultants Program. So what are our objectives in OneOkie AIC? Well, first, of course, is providing the AI consulting to the target audience. And that lets them adopt and adapt AI techniques and technologies into their research projects. So the idea is, if a research project wants to use AI but doesn't know how to get started, then the AI consultants are there to help them implement. And if they're already using AI and they want to improve that use, then the AI consultants are there for that. So there's sort of these two camps, the help me get started camp and the help me get better camp. We also, part of our charter is to provide AI training across the state, but in fact, the AI training is valuable for anyone. It's not state specific for the most part. And so we will invite basically everybody around the country and honestly around the world, since I have a giant spam list that many of you are on. We'll invite all y'all to come participate in that. Probably the only one we wouldn't invite you to is how to use Oklahoma resources if you're from outside of Oklahoma. We're probably not sending that to everybody. But all the other stuff we're going to do, probably everybody gets invited. Sorry. Everybody gets invited to probably everything except how to use Oklahoma resources. All right. Cultivate a cohort of student AI consultants, so mentored by the professionals. Create a national AI consultant workforce development program, and show the value of what we're doing through our evaluation process. So formative evaluation, that is during the project as it goes, and then summative evaluation at the end of the project. All right, so 94 projects from 9 institutions so far, 2/3 of them, slightly over 2/3 of them, at OU, the remainder around the state. And I listed them in reverse order of number of projects. So these three at the top are non-PhD granting institutions. They're all master's granting. Here's two non-academic. One is a nonprofit research institute, and the other is a government agency, part of NOAA. Then here's a master's granting in our three PhD granting institutions. And you can see the project counts. And if we tote up the amount of research funding that those projects, and I can't say has, because I haven't repolled them, but had at the time we submitted the proposal last summer, it was about 124 million of active funding and about more than double that in pending and planned funding. I confess you can hide a lot of sins under the word planned, because that's proposals that haven't gone out yet. Pending, those proposals are out and under review. And that represents, according to our research stakeholders, that represents over 750 researchers, faculty, staff, postdocs, grad students, undergrads, and we had them all break it down that way. I am not going to read these slides out loud. This is just some research topics. Is not by any means the complete list. Sorry, this is the complete list, excuse me, other than the three new ones. I haven't bothered to put them in here. These are some of the departments. You notice I alphabetized them, and number 50 is N, so you can see it keeps going after that. So a lot of different disciplines. So 71 departments. That's kind of a cheat in the sense that, both Oklahoma State and OU have computer science departments, for example. So it's not 71 different disciplines, it's 71 different departments. Okay, let's talk about the AI consultant. So what is an AI consultant? Well, to start that, let's start by talking about two roles that I think we all do have a pretty good feel for. One is a cyber infrastructure facilitator, and we understand what those folks do. And one is a cyber infrastructure research scientist. You might call them a computational scientist, or here you might say an AI research scientist, someone who would be part of a research team, but they would not have domain-specific expertise. They would have AI-specific expertise. So the CI facilitators, their job is to get people up and running and then over speed bumps. And they may have some deeper roles from time to time, but to first order, they're kept pretty busy by the research population of the institution. Certainly that's the case here at my institution. So their participation in any specific research project is relatively superficial, mission critical, but not deep. A research scientist is the exact opposite. They are part of the research team, and so their depth is great. But on the other hand, there's a very limited number of research projects they can be involved in because there just aren't enough hours in the day. And so they might be in a handful of projects, whereas a CI facilitator might interact with hundreds of projects even per year. A research scientist is going to interact with a handful of projects per year. Then the AI consultant is going to sit in between those. So have a deeper relationship with any individual research project than a facilitator, but not as deep as a research scientist, and not doing the work for the research team, but rather helping the research team to learn and to execute that work. So what are we going to be having them do? Well, first we got to get them on board, and as I said, we've just onboarded two of the new professionals, and hopefully very shortly we'll be onboarding the undergraduate, and available across the state and across all non-clinical STEM disciplines. And I'll talk in a little bit, but we have a mechanism just at OU, not across the state, just at OU, for non-STEM, so for example, digital humanities, and for clinical research, but that's paid not by NSF funds, it's paid by internal OU funding that pluses up the salary and fringe of the professionals. And also, pays entirely, internal funds pay entirely for the undergraduate. Only the graduate student, among the students, only the graduate student is funded by grant funds. Okay, so what are they going to do? Help research teams adopt AI into their workflows, um, or if they already are using AI, to improve how they're using AI. And improve here has multiple definitions, right? One would be improve, for example, the specific techniques that they are using. The other might be improve the efficiency of those techniques, changing how they do the calculations in order to do them more efficiently, faster, perhaps consuming less resources or whatever it may be. Porting the AI workflows to relevant platforms. And here I don't mean, for example, to a new version of Linux. I mean to specific individual resources. Some of those at specific institutions. So I mentioned in Oklahoma, we have the 5 resource provider sites. So they are targets in this context. And then also national resources. So NAIR and Access and the National Research Platform and OSG that used to be Open Science Grid, but apparently now is just OSG, and so on. Develop AI software templates that or leverage ones that are already available. And this may be where some of you folks come in for common categories of AI use cases. So if someone's doing image classification, if you've got a template for how to do image classification, it's much more straightforward to get someone up and running because you're not having to create that Python wrapper around TensorFlow or PyTorch or whatever from scratch. You can start from the template and then tweak it to the specific needs of that project. Then provide regular training events for researchers across Oklahoma and, in fact, nationally and even internationally. Anybody on the spam list is welcome to come. Although, again, for the session on how to use Oklahoma resources, we figure that's really only valuable to people in Oklahoma. And then create the National Workforce Development Program for AI consultants. And I mentioned already the expertise pipeline, so I won't belabor that, but that should give you a feel for the individual components. And then our approach to this is, someone will meet with the CI facilitator, and the CI facilitator will say, "You're a really good candidate for AI consulting," and throw them into the meat grinder of organizations of research projects that need AI consulting. And then if the AI consultants recognize that that project needs deeper expertise and collaboration than the AI consultants are positioned to provide, then they refer them to AI experts. And so we are developing a pool of AI experts. In fact, I was at University of Central Oklahoma, I think a couple of weeks ago, for a meeting, and there were some folks from there who, when I explained what we were up to at one of the panels, they got very excited and they said, "We want to be AI experts. We want to be part of that pool and get matchmaking." So we're going to be creating this matchmaking capability. And we've recruited some, but we, of course, want to recruit more. Can you comment on what role team members of OneOki AIC might play in AI curation, governance, and/or management? That is a very big question, Carl, and I like that question, and I'm not sure I know how to answer it. So I'm going to answer it 2 ways. None at all and probably a lot. And let me be specific what I mean by that. Those 3 roles are not part of what we proposed to the NSF to do. They are not covered under what the NSF funding is intended to accomplish. Having said that, we are very aware of the value of cultivating those kinds of skills within the institution and within the state. And so I think you are correct that it is inevitable that that's going to end up happening, that when these issues are coming up, we will say, "Oh, one of our AI consultants should serve on the committee that's developing, for example, the policies for AI curation," or whatever it may be, that so-and-so is a really good candidate to contribute to that process of developing policies or capabilities or whatever it may be. So your question is very timely. I don't know the answer to the question, but I think the answer inevitably will be they will play a role and it will be a significant one. All right, Alan says I'd be interested in some metrics on AI workloads by type, resources needed, resource providers utilized, etc. And I think that's a great idea to collect metrics of that kind. Since we're just getting started on this, we don't have those metrics yet. And it's very difficult to ask faculty when you're writing the proposal, which is where we collected the metrics we did collect. It's very difficult for faculty to provide that kind of information. Um, because they don't know how to measure that, and they typically don't pay attention to it that much. The
Okay.
most they would know is when I do a run, it takes N days to complete, right?
So I'll take your interruption token up if I can.
Please.
So this is you're correct that it will require more metrics of the sort that several of us have been active. I'm among the group, but certainly not the majority provider of such metric papers. But there are lots of them out there. We do need to extend it. However, my question is a little more immediate, and it could be done, I think, as quickly as asking your AI facilitators how many people they've steered to NAIR, for example, and what, whether any of those have gotten awards and what they're using them for. Or if it's
Right.
too early for that,
It is
yeah.
in the specific context of AI. I can tell you that our CI consultants have, for the most part, not had situations come up where the obvious solution was to steer them to Nair or Access or that. OU, as an institution, is one of the top consumers of Access and has been through Exceed and I think even in the TerraGrid days. And I've been tracking that intermittently on XDMod. Um, I think in a typical year, OU is usually in the top 30 and almost invariably in the top 40 um,
So
on
you're
XD
still
mod.
in
I'm sorry?
the you're still in the answering questions, getting people up to speed mode.
Right.
That's the kind of consultancy that you're doing. It's not yet turned into a whole stream of output that you can go look back
Correct.
at and start measuring,
Right. But to
Yeah.
clarify, the NSF made very clear that that was very important to them that there be a significant um, result of transitioning local users to national platforms as their needs grew. So that will definitely be a component of this, but correct, I don't have any metrics this early.
Yeah, I ask because uh, this will be a humble brag, but it's not intended to be. Um, I'm in the situation of having the university have made the financial decision to invest substantially in AI resources before they bothered to ask the faculty what they would use them for. And so I really want as much of a forward look as to what's actually useful as possible. Also, we run an access facility, and we're always interested in use cases.
Sure. Yeah. I can only say this locally, we don't have any difficulty keeping our GPUs full. So that's a very crude metric, but I think that captures at least something important about what's going on. And I imagine that other institutions would say similar things. Um, if we had twice as many GPU cards, I don't know that we would immediately fill them, but our researchers would grow into them without difficulty.
Henry, if you don't mind me chiming in just a little
Please.
bit, this particular question from Alan actually resonates pretty well. We had a similar question came up in one of the other talks in this particular group, and Xalt and some other in-house brewed metrics actually came up, like ASU was actually developing it, and they were able to look at some of those AI workloads that are running on their systems. So some of those combination of tooling in conjunction with XDMod can actually provide you some of those more specific metrics on utilization of resources. So I think, Alan, maybe I misinterpreted your question, but I felt like you were trying to get to some of those specifics. So there is a somewhat of a combination of tooling that could potentially address some of those questions.
So I'm sort of priming the pump for Henry's next set of deliverables, as he described. And if I can help with any of this, please feel free to reach out. We've been through several
I
such
appreciate it.
papers.
Um, so I think I mentioned about the AI experts, and so I'm not going to spend a lot of time on this, but um, this was something that came up in writing the proposal was we had a number of faculty who had AI expertise, but were not therefore going to be consuming the service who said, well, this looks to us like a really good way for us to find research collaborators to use the capabilities that we create in our own computer science or what have you research. So how would we be able to contribute to that? And I realized that the answer was, well, I can't pay you any money, but maybe some of these researchers can because they're going to need something beyond what the AI consultants are going to be able to do. Um, and so, by the way, be able to do here meaning have the wherewithal to do given the scope of their duties. I would expect that most of them would be able to contribute and become parts of individual research projects if they had time to do so. They just don't have time to do so. Okay, so this is what led us to the idea of the matchmaking service. And so we also have this. So that's sort of the pipeline of facilitator to consultant to expert. We also have the professional development pipeline of um, undergrad to graduate to professional, where there's mentoring happening among the levels and peer mentoring happening within the levels and so on. Because what we ultimately want to do is we not just have this capability at one institution, but it become normal. And part of it becoming normal is getting people into that professional pipeline, getting them to recognize that that is, in fact, an opportunity for a career. That's a little ad hoc today, but our hope is that over time it will become increasingly normal. And what happened for facilitators, for example, will something similar will happen for AI consultants because we can see that this kind of capability is going to be needed across research intensive institutions. Okay, and then our engagement with the national cyber infrastructure groups, and I rattled off a set of them, and some of the resource providers, of course. Um, so how do we engage with those? When we wrote the proposal, the difficulty was we had a very, very compressed timeline. We had, um, I guess it would have been 5 weeks to write the proposal, give or take. And that was really challenging. And it was not possible in that time to come up with a plan for actually how to accomplish this. So instead of trying to fix the problem in the proposal, what we did instead was we appointed an external advisory committee consisting of representatives of these organizations, which gives us a conduit for developing a strategy for this during the project itself. Okay, so the training and workforce development. Um, so we have a sort of straw man list of topics, but of course this will evolve over time, and I'm sure we will have other topics. Some of these topics may drop out. So one of them is no code AI, because a lot of our researchers simply don't write code, and even expecting them to write a Python wrapper around an AI library is not realistic. And one of our co-PIs on this project has been developing a no-code solution called Zero to Neuro. And so, in fact, our team is helping contribute to that development. And that is a quick and dirty way to get a research team that's not using AI yet up and running on using AI if they don't have a coding skill set. And then low code solutions using templates. Now, it may end up that we've got all of this stuff sufficiently covered in Zero to Neuro that we just go with that, but we're also open to Python templates for common use cases, like if there's an image classification thing and we have a template that does that, and then you're just tweaking that with what you're doing to bring the data in and maybe some pre-processing or whatever it may be. Um, One that seems really important, and we actually made this a question for interviews, and we've interviewed a lot of people, um, is storage hierarchy issues. Because, of course, if you can get the data to the fastest storage by the time you need it, the GPU card is going to spend a lot more of its time crunching numbers and a lot less of its time waiting for numbers to crunch. And so we want to have the AI consultants training our researchers and yours ideally on how to work with the storage hierarchy. My experience has been that the overwhelming majority of researchers have zero awareness that there even is such a thing as a storage hierarchy. And that puts the onus on us who are aware of this to help them understand first what the storage hierarchy is and then what to do about it. Using Oklahoma compute resources to do AI research, and then using national compute resources for AI research. And this is why I want to split these out as separate training modules, as separate events, because I think the interest and uptake for how to do it in Oklahoma is going to be largely limited to people in Oklahoma, whereas for the national resources, that's going to be valuable across the country. And then something that we got a lot of feedback from our researchers about is they really want, they called it real time. I'm going to call it on-demand inferencing. They want that when they're going to do an inferencing run, that run goes immediately. As far as I can tell, there are three ways to accomplish that, and two of them are much more expensive than you really want. Mechanism number one is everybody gets a fast workstation on their desktop or a really hefty GPU in their laptop. The difficulty with that is now you've got a zillion assets that are idle 99% of the time, and you've spent a lot of money on them. That is not a scalable approach unless all of your researchers can afford the extra however many $1,000 per PC to make this available to everybody on their team that needs it. And that does not seem realistic to me. I recognize, and this was actually the preferred solution that the faculty came up with, and I understand why. Faculty love to hug their toys, but the difficulty is it's going to be an enormous amount of money out the door for very little return per dollar invested. So we don't like that solution. And the university, using internal funds, is absolutely not willing to pursue that solution because, again, they're going to spend a lot of money and get very little value for that money. The second option is to go to the cloud. And that is an option where you absolutely will get your on-demand turnaround because the cloud has effectively unlimited capacity. It's not literally infinite, but it's arbitrarily large and can grow with demand. So if they anticipate that demand is going to be such and so, and I'm sure they have giant spreadsheets that do all these calculations for them, then they can say, all right, we need this many more of this kind of card and that many more of that kind of card, and here's the servers we need, yada, yada, yada. But the cost is a lot more. So depending on which commercial cloud vendor, and I looked at the top four, it's going to be anything from 500% as expensive per unit of computing, of GPU computing, to 2,200% as expensive. Although the one that was 22 actually has come down now. It's merely a factor of 20 more expensive now than it used to be. Now, that particular vendor, they said, oh, we have this special academic program where you can get an 80% discount on that, which means it's merely a factor of 4 more expensive. But it turns out that in order to get that discount, you have to spend mid 7 figures per year with that company. And not every research-intensive institution is going to be able to accomplish that. So you get a great big discount if you've already given them a lot of money, which is not practical for every institution. And in fact, I would argue most it's not practical. Oops. Okay. Then on the workforce development side, we will be creating a virtual residency-like program. In year one, we'll design the content of that program, just as we did with the virtual residency. So back in 2015, the OU team designed the entire workshop, some of which meant inviting speakers, and then they wrote their own materials, and that was fine. But we designed the structure of it. We created a lot of the materials, but by no means all the materials. Starting in year two, we had the community say what was needed, and develop a lot of the materials. So now the virtual residency is entirely developed by the community. We do a poll to see what the consensus is on what the high priority topics are. The top ones, they get stuck into the agenda, and we're good to go. And then we recruit people. If it's a talk, we give them, here's the previous slides that people used over the years, do with them what you like. And if it's a panel, then there are no materials, so you don't have to worry about it. So what kind of topics are we talking about? Well, of course, we need an overview of the workshop, assessing where a research team is on AI and what they should be doing. That's obviously a really core AI consulting skill. Figuring out where are they, where do they need to get to. Teaching non-programmers to use AI. Henry, did you skip the third and presumably preferred way to? Oh, sorry. Yes, sorry. Thank you. I did skip that, so let me answer that question. Um, the third way is to train people who are doing big, long training jobs, not inferencing, training jobs, to use the checkpointing capabilities that are built into the popular libraries like TensorFlow and PyTorch. We've done experiments. We're not in production on this yet, but we've done experiments with this, and it actually works really beautifully. So you have a job running in the killable queue, and it is checkpointing through the software, right? We provide the template for how to do that so that it's minimal thinking on the part of the researcher to stick it into their Python wrapper around TensorFlow or PyTorch. And then it's just checkpointing regularly. And the thing is set up that if there exists a checkpoint file with the appropriate name in the appropriate place, then restart from that checkpoint file. If there isn't such a file, then you're starting from the beginning, and that hopefully that's on purpose, right? So essentially, when a job appears in the preempting inference queue, and these are relatively short jobs, a few hours at most, then the training job that's running and that is checkpointing itself through the software will be killed and requeued. We haven't really decided yet whether to requeue it with next to run priority, like a big priority bump, or whether to just put it back in the queue and it runs when it runs. We haven't really thought that through yet, but and we've tested this and it works great. So the inferencing job can kill off the checkpointing job, the training job. And then when the inferencing job ends, then that opens up that GPU to be exploited by another job. And again, we haven't decided whether it be the job that just got killed or whether it would be some other job that had been waiting in the queue longer. I don't know. But we'll figure that out based on how much screaming the researchers do. It's fine. Can you also comment on any priority on raising awareness for data sovereignty, data exfiltration? We are not attempting in this project to address policy issues. There are organizations at our institution that are doing that. And as we talked about before, I think it is high probability that our AI consultants would get involved in those discussions and would contribute to them. But that is not specifically part of their role as an AI consultant as such. I hope that helps answer that question. To what degree can the interactive, interesting parts be handled through interactive tools such as Open on Demand, leaving processing jobs to be managed through batch? So there certainly is an opportunity for that. The difficulty is that then you have to keep resources specifically idle for interactive use. And given the extremely high cost of these resources, my gut reaction is if they are kept idle for interactive use, then I'm going to get fired because we'll be wasting the university's money. The alternative would be, and in fact, inevitably it works out this way. Like, unless you have a ton of interactive resources, I don't know how you keep people from fighting over them. So you can put severe resource limits and say, okay, I'm going to shard this GPU card into the 7 MB shards and make those available for short periods of time. But if you can't do that, and even then it's not guaranteed, I mean, how do you keep people from fighting over the interactive resources? Because after all, if they're expecting to use something interactively and then they have to wait for 10 hours, they're furious. right? That's not interactive. I don't know how you do that when you have a popular resource and limited funds. Can the checkpoint file save the previous results before termination? Um, I'm not sure exactly how to answer that question. The checkpoint file saves the state of all of the relevant memory of, and I think it's both the GPU memory and the server RAM, although I won't swear to that. And I don't mean literally all of it. It's not a core dump, but call it all the variables. And I don't pretend to understand how any of that works. That's in the guts of TensorFlow and PyTorch, but I believe they both have that capability. Uh, I'm not sure of the particulars of that. Okay, so sorry. Thank you for reminding me to go back and discuss that. And I'm down to 5 minutes. I ain't gonna get done with anything. Let's just get through what we're gonna teach at the workshops for the AI consultants. Um, teaching non-programmers to use AI, so that's the zero to neuro thing. Teaching inexperienced programmers to code for AI. Determining a research project's optimal AI resources, right? How do you figure out what resources they should run on? Should they run on your local resources? Should they run on CPUs instead of GPUs? And we've encountered projects where that was the better answer. Should it run at national resources or on some other institution within Oklahoma, right? How do you figure that out? How do you figure out where a particular project should be using the resources um, based on what and how, what they're doing and how they're doing it. And then a panel on researcher perspectives. What are the researchers wanting? Okay, how about professionalization of AI agents as a more active collaborator in the research loop or research software loop, human AI teams? Certainly that is a possibility. I think that's probably underexplored here at my institution. Um, Okay. So one of the things that I've noticed from interviewing a substantial number of undergraduate candidates is that there are a lot of people who, in their mind, because this is what they're exposed to, they think that AI is the same thing as LLMs. They do not think LLMs is just one flavor of AI. They're not aware that there are other flavors of AI. Um, the kinds of research that we are set up to support include things like LLMs and agentic AI, but are by no means limited to that. In terms of using agentic AI for things like research workflows, I think we're all going to be learning that together at the same time. I don't think that's something that the AI consultants magically already know about because it's a very new thing, and a lot of research teams are not yet doing it. And thank you, Faru, for alerting me that we're out of time. I am delighted to report that I got through slightly more than half of my slides.
Thanks.
Um, so uh,
There's
um,
one question, one
yes.
last question.
Let me scroll back to it. Hang on.
It's
Trying to grab it here.
that's
Okay, to what degree can the interactive inferencing parts be Oh no, that was not that one. Professional and humans learning to use these AI tools and collaborators in single player versus multiplayer mode. I do not know. You are way past my level of expertise just in the question you're asking. I really don't have a good answer to that question.
and you still have 2 more minutes, Henry.
Okay. To what degree can interactive inferencing parts be handled through interactive tools? Okay, I think I already addressed that.
Yes.
How am I running multiple LLMs, single H100 challenges, I don't, am I fundus? I don't know what that last part is. I mean, I can look at that article, but this is fairly greenfield for me. But honestly, my experience has been um, if there are many people fighting over a resource, the only practical mechanism, and here I mean a computing resource, the only practical mechanism for managing that is batch computing, because if you use any other mechanism than that, everybody is mad all the time. And this is an example that I give when I give tours and I explain why we use batch computing. So the most obvious brute force way to do this is just let everybody run on everything all the time. But we know that the result would be a disaster. The best you could hope for would be everything would run super slow because there'd be a ton of different things running on the same resource at the same time. In practice, what we would actually expect is everything would crash all the time. In either of those cases, that would just mean that they would send me a bunch of hate mail, and all I would do all day would be answering hate mail. And of course, I wouldn't be able to do anything to satisfy them. So then they'd send hate mail to my boss, and he would have to fire me because all he ever gets is complaints about me, right?
Yeah, I agree in general. But I bet you that we all have small workarounds. For example, on our cluster, we have a thing we call the GPU build node that doesn't have restrictions on the number of people who can log into it. You're competing for a resource, but it's intended to let you just compile and do a quick test on your
Right. When you're using it
from
for something very lightweight. I
yeah.
just don't think that AI calculations come under the heading of very lightweight.
I agree in general, but that's why I posted the link. In addition to the multi-instance GPU capabilities of modern GPUs, there are tools like this one that's just a LinkedIn post so far, but things that let you share uh, a resource more broadly. So you get to the different kind of oversubscription, much like the way we use our GPU build mode, but you can get leverage more out of your resources. That's the stuff we're looking into.
And I am sure there are instances of that. The problem is you have to carefully manage what people can do on a shared resource. And in my experience, that is extremely challenging in practice. That you get a bunch of grad students on there, which is what most of our users are, and they have not had any training in this, and you can tell them what the rules are, but my experience when you tell people a large number of rules, they remember 10% of the rules and they flip them in their mind. So everywhere you said don't, they do, and everywhere you said do, they don't. And so I despair of providing more than a minimal amount of interactive AI capability because all people will do is fight over it. This is exactly the reason we have batch, is because the alternative is nothing works. All right, that's a debate for another day. I appreciate everything you guys have asked, and all of the back and forth has been really fantastic. I think this is wonderful.
Yeah.
I'm sorry we ran out of time, but I had a grand
Thank
time
you,
getting halfway
Henry.
through my slides.
Thanks so much, Henry. Thanks, everyone.
Bye, all.
Thank you, Henry. Terrific presentation, as always.